not that many. People come to the Plains for the first time and they're like, wow, what is it you guys do? And I'm like, we have a good time. Except there's information, but this is not,
Yeah.
this is not work.
It's about the good time.
This is not work.
All right. Ed Williams is going to take us home.
All right.
Right.
Okay, got a short little presentation about 3D printing. Only 50 so slides, so I'm going to breeze through it as fast as I can. Okay. By the way, I'm new to this. If you have anything to add, please feel free to speak up. I learned because a handful of people on the forum were doing it, so I figured it seems like something I should get into. So anyway, I'm a novice still, so please speak up and add anything that you would that you think is relevant. Okay, today we're going to talk about 3D printing top down, just a high level overview, how I got into it, and the parts that I've made, and I'll tell you a little bit about each of them. We'll talk about the process of designing the parts, the 4 steps. Go over filament and printers. Couple of tips and tricks, tools that you're going to need, some FAA stuff, very brief, and some Q&A. Also, I've got some things to pass around, so I will do that in a few minutes. Okay, so 3D printing, additive manufacturing, high level umbrella term, additive manufacturing, different from subtractive, right? You have a mill, takes away stuff. Additive manufacturing adds stuff layer by layer, general principle. Okay, 3 main types that are common. Number 1, SLA, stereolithography. This is so you have a vat of resin, and you have this plate that slowly picks the part up out of the vat of resin. It uses lasers, and layer by layer creates a part. These parts generally are smaller parts. You can make very high resolution, very highly detailed parts with this. The common uses for this I see are people who play Dungeons and Dragons print little tiny, highly detailed figurines. So I didn't get this one, but this is one of them. You'll find this SLA printer. I passed. Next one is selective laser sintering. This is the one that's it's industrial printing. This is how you make metal parts. So what you do is you take you have a layer of powder, and lasers go through and they harden a layer of powder. You put another layer of powder, another laser pass over and over, and you can get metal printed parts doing this. These cost about $20,000 right now for the cheapest ones. There is a company trying to make one for $5,000, not out yet, but they promise coming soon. But generally impractical for hobbyists. This is the one, FDM printing is the most common one. And when people say 3D printing, this is the one they're talking about. So I'm going to talk about this one today. It's generally, or relative to the other ones, it's lower resolution, but far cheaper, all plastic filaments. And there's a ton of them. This is the one, you Google 3D printing, this is what's going to come up. All right, so in general aviation, the applications generally are quick iteration, quick prototyping, and if you need a one-off item, this is very relevant and very easy to use, easy to apply to general aviation. The way that I got into it, a couple of people had uploaded files to the forum, and I went on there and downloaded the files, printed it myself, and now I had a piece that I could put on my plane. It fit perfectly. Marcos is one, Joel another, as a handful of others that have put them up there and made parts that I installed on my plane. Next. All right, so where it all started. A little of this is cut off here, but where it all started, I was redoing my interior, and I wanted to install new ball vents on the top. In the headliner. So I found on Spruce there is a Avio Air ball, like it's aluminum ball. It's $100-something. But on the back of it, it has a little thread. It's threaded. So it wouldn't fit in our little square manifolds that we have. And plus mine were all cracked and busted. Anyway, so I'm trying to figure out how do I get a manifold that fits in our headliner that is threaded for this ball vent. I contacted Avio Engineering, and they said, yeah, we have one, but we don't make it anymore. We could custom make it. It'll be pricey. But they basically told me to go away. But they sent me the engineering drawing. So I took that engineering drawing and I went to a prototyping shop near my house, and they said, yeah, no problem, $2,400 per part. So plus tax, 10K for these 4 manifolds. And I said, okay, never mind. So, so anyway, so I took that engineering drawing. I took it to, at this time, I didn't know anything about CAD, didn't have a printer myself. I took it to a place online that's called Fiverr. And I found somebody who, the guy, he's a mechanical engineering instructor in Philippines, I think, paid him $25. He turned that drawing into a part. And if you go to the next slide. So I gave him this, he gave me this. And then after I got a printer, I printed this and it worked perfectly. This is a perfect fit. This is the exact part that they had given me. I did make one modification. I changed the size of this little, whatever you call that. I changed the size of that to fit our scat tubes. It was a bronze size. So I asked the guy, hey, while you're making the part, change it. No problem, he said. So anyway, so this one fit perfectly. Ended up making some more edits to this design. Cost me $25, but that's fine. If you go to the next slide. So if you can see here, I wanted to make the tube a little bit longer, put a little nub on the end so that it would, we could put a clamp on it, wouldn't slide off. But that's not what this slide is about. So when you're doing 3D printing, you can't print in, open space. You have to use these little supports. And so this is what the support looks like here, and it holds up the print while it's building it layer by layer. There's two ways to, or there's a couple of problems with this. Number one is you get like a, whatever you call it, like a rough interface between the support and, like right here. So you either have to do post-processing on this and like sand it, or what you can do is you can use an interface layer of a different material type. In this case, I ended up using a different material. This one I printed out of an accelerant, basically. This is ASA, and so it's extremely flammable, and I ended up not using this part. Yeah, I'll talk about that in a second. But anyway, number one is handling overhangs. You got to use these little supports. Very easy to use, and I'll talk about that in a second.
Excuse me, please. Can you show the slides online, please? Or move the camera.
I'm so sorry.
Or move the camera a little bit to the left.
It doesn't work very well because it's just, there's too much glare. So I will share. I'm very sorry about that. Thank you for letting me know. I think I have to.
Any questions so far? Super clear. Yes.
You have some type of file, CD, chip apart, stick in the printer to make this all work.
Yes. So there's a couple of ways that you can do it.
Why?
depending on the printer you
David,
get. The one that I have, you can.
why is it doing this?
To go over Wi-Fi. So on my computer, I just hit print.
Oh, never mind. It moved up.
Here, print 1,000 miles away at my hand.
There you go.
Some of the other
It
printers
was hovering down. I don't know why.
Oh, it's future math.
Yeah.
And yes, on the file too, you have to get this, they call it STL file or STEP file. It's a CAD design. I got mine. My first one's from for $25. I ended up making it after that. Some of my other ones.
Somebody's got design all of this.
Yeah. It's easy though. It's easy.
Sure.
It is. Yeah. Well, it's easy to start. It's hard to get good. It's one of those that there's a
Steep learning curve.
Yeah, you can make simple things, but I tried to make some very complicated ones, and that's when I go pay that $55. So SolidWorks is too expensive for me. I'm on the free, if it's free, it's for me plan. So I'm using Tinkercad. Free online, you can do as much as you want. I started to learn OpenCAD or FreeCAD. The other ones that I said,
She does laser center on SolidWorks.
yeah. So SolidWorks is the one though. That's the one. If you want to be serious, that's the serious one. Ah, come on. You got to use that family connection.
And we point out, you're a member of, EAA, not SolidWorks, but they've got a real CAD, it's free.
That's great. Okay, I gotta look into
It
this.
is all.
No, they changed just recently to something else from Siemens.
It's, they still give you they'll give you the cloud version of SolidWorks, they won't give you the desktop install.
Oh,
Mm,
yeah,
So you, but the cloud version is not.
okay.
Yeah.
One other thing is if you're paying tuition for any of your children, they can get the collegiate license for $25.
yeah, there you go.
So,
Just sign up for a class at the community college. And then, yeah. Are we good to go?
Yeah.
Oh, yeah.
Yes,
Okay.
we are.
So, one other issue that I ran into with the ball vent is that it's threaded. Threads are notoriously hard to print just because there's tiny little edges and everything. And on top of that, these plastics, they shrink just a little bit. And so if you want a tight fitting thread, especially for something where there's going to be air going through, it needs to be nice and snug. You have to get exactly the right fit. And so these plastics or this particular material shrinks at about 1%. So I had to do these. This is the way I did this. I printed like 10 of them. And I said, okay, this one, zoom it by 0.5%, 0.8%, 1%, 1.2%. And I found, I think it was the 1.2% one fit the best. Not too snug, but I could get it all in there nice and tight.
Or is it shrinking the curve?
Immediate. Yeah, it's like as soon as it cools. One other thing I'll talk about this in a second too. While it's cooling, don't touch it because these things will warp. And so while it's cooling, you want it to cool nice and evenly in the print chamber, and that'll prevent warping or reduce warping. All right, next slide, please. So another thing I printed, I needed a new little breaker panel. So I had 5 breakers that I needed to install in my aft wall. This one was really easy. The spec for these Clix-On breakers is available online. So I know exactly the hole size. I know exactly the distance between this little key and the hole and how big that key needs to be. I put it into, this is Tinkercad here, put it in there, printed a couple of tests. Perfect the first time. Lucky on that one. Added some support, and then boom, I have a new breaker panel. This one was nice and easy. I loved it, and my A&P was like shocked how easy it was. All right, next slide. All right, anyway. Okay, next one is a panel-mounted dimmer. So I was installing a new under glare shield LED strip, and it has a little dimmer that comes with it from Aircraft Cruise. I needed somewhere to put that potentiometer, and I had an open hole in my panel. So in this case, I was about to go design this part, but I said, let me just look up online. And somebody in 2016 had made one with the perfect holes and the distance and the dimensions. They had uploaded it. I downloaded it for myself, tested it, fit perfectly. And if you go to the next slide, I went and then I measured my dimmer, fit the hole and the key exactly, and then subtracted it from their part. And then installed it in my panel here. So now I have a place to put this instead of drilling a new hole in my panel, or I was gonna stick it to the bottom. That was not allowed. All right, next slide. Okay, so next one was wire clip. So I installed that digital dome light controller that's on the forum. And so I was replacing the wires, all the wires for all of the lights, and I wanted to. I was using those little 3M sticky pads that are just trash. So they either come off immediately or they come off later when it's hot. So I figured I want something that's going to be a physical connection that's never going to come off. In this case, so I'm designing these little clips here. They clip on there's like this L bracket that goes along the roof. And it's like an L this way that goes backwards and an L this on the longitudinal axis that goes out. So I designed two little clips that just hold those wires nice and snug, and they snap on, and they're never coming off. In this case, this is made out of polycarbonate. It's never going to break. It's never going to deform. It is it's a permanent thing. On the front part of the plane, there's no L bracket. It's like a flat piece of aluminum with rivets on it. So I modified it a little bit and put tiny little holes in the clips. So now it snaps over a rivet head, and it just snaps right on there, never coming off either. That one. All right, next slide. In the tail cone. So this one, I had all this bundle of wires from the digital controller that's installed down here on that plate, on that flat plate behind the battery. Behind the pump. So anyway, so I designed a little clip. It's like, oh, it's here. I'll pass you down in a second. So designed a little clip that it snaps over, the rib, such that it like this little tooth, I guess, this little tooth snaps behind it, and because it's a little bit too small, it's never coming off either. In this picture here, I put a little clip on the top and tried to tuck all the wire underneath it, and I found that was very annoying. So I modified it, and these versions have a little hole, so you just put a little zip tie through it, and then you can secure the wires that way. And here, I'm going to pass these around here. Please feel free to check them out, take a few, and everything that I pass around is either going in the trash or you're taking it. So please take whatever you'd like. All right. Next one is, it always bugged me that the tow bar is always just on the floor, moving around. So I wanted to mount the tow bar to the back wall. In this case, so I made a handful of prototypes, also Tinkercad, and finally got one that I liked and printed it in black, because of course. And so then I got a way to mount my tow bar. It just snaps right on the back wall. Anyway, I didn't share this file, but I'd be happy to. All these files I'd be happy to share later. I don't think I shared all of them. All right, okay.
Hold it out.
Probably not when you snap it in, it's not putting so much pressure.
No, so this particular plastic is also polycarbonate, and it's a very strong, very durable plastic. With these little clips that I'm trying to break one, it's tough. And in this one, I printed it almost solid or solid. I can't recall that. But yeah, it's not going anywhere. It's going to last longer than me or the plane. All right, next one. Okay, so I should have posted a better picture, but on the back wall, so we changed it and made it a flat piece instead of the little hat rack. And so then there's a large panel that's removable, and I just snap it right to that on the back. We use little metal clips, like little spring clips. So I hook it on that back one, and then the handle snaps into the metal spring clip, and it's solid. Yeah. My mechanic wanted me to put a little pin through it too. That way it's never coming off. I've taxed it around without the pin. It's fine, but to make him happy, I put the pin in. Yeah. Every time I could hear something, it's like a little metal clinking, you know. So I wanted it just secured and out of the way. All right, so that was my journey. I have designed a handful of more things. The idea here was to give you some ideas of things that maybe problems that you have, or things that you could build, or things that you could just download and print for yourself, or whatever. Okay, step by step. How am I doing on time? Good. Okay. All right. So step by step. So number one thing. So measure, model, slice, print, 4 steps. First thing, measurement. Everyone here is very technically inclined, I'm sure. So that part you probably are pretty good at. So okay, if you can stomach it, the printers are all in metric. and you can't get away from that. They print in millimeters. If you can stomach it, stay in metric the whole time. You can measure and you can design in standard. It's fine. It works. Just was a little bit simpler for me, at least, to just measure in millimeters, do it the whole time. Millimeters. I'm printing millimeters. I know that it has 1,000 layers at 0.1 millimeter depth. I know exactly how big that is and if it's the size that I measured. You're right. It's simple enough. I could do it. Yeah. You don't have to, but I recommend it. And so, the method that I use is I take my caliper and I just hold it next to whatever I'm measuring, and I take 1,000 photos. And so then I usually will find out later I didn't take enough photos, but it makes it really easy to understand for me that this was the dimension I'm measuring. This is the caliper, and that's what the caliper read on it while I was measuring. It was just easy for me. All right, I'm going to go over each of these. So next slide, please. All right, so this caliper, you may have this one. It's 24 bucks on Amazon. It's great. It's battery powered. It's digital, easy to read, easy to take pictures of. Recommend it if you don't have one. This one is 6 inches, which is not quite long enough for the print surface that I have. They have more expensive ones that are longer, but I don't use this. Next. All right, so 4 different classes of CAD software. I'm going to talk about the one that I use is Tinkercad. This is where you take shapes like cylinders, pyramids, squares, whatever, and you add and subtract them from each other to design the part that you want. It's very easy to wrap your head around. I know that for this, for example, it's a pyramid sort of with the point cut off, turned upside down, right? And this is a cylinder that's very flat, very short cylinder, right? And it's very easy to figure out. The more advanced CAD softwares are they're better. You can print or you can design more complicated objects, like those threads, for example, is impossible to do. So I should not say that. It is possible, but it's very hard to do in the geometric version. What you want to use is the parametric CAD software. I haven't learned these yet. You can go all the way down to like Autodesk Inventors. I hear is very good. Some people are doing things in something called Blender. Blender is it's software used to make like video games and more human forms. You can basically draw in 3D space, and then they've built a plugin that you can export that to a CAD file. I haven't dealt with any of that. Your mileage may vary. All right, next. Okay, so you can not do anything yourself and just outsource like I did for my first one and a handful of more complicated ones. I use this website, Fiverr. This website's just a contracting website. You can go on here. This guy, this is the guy I used. I found his ad, paid 25 bucks. It was great. He did it in like a 24-hour turnaround. It was amazing. There's a handful of other websites, CAD Crowd. You can go on Etsy and get stuff designed. You can go in. There's tons of places to get things built for you. All you need is specs, and these people are very helpful. This guy will offer to do a video call where you just explain what you want, and you say, "I think it's like this size," and he'll do his best to make it for you. Still 25 bucks. All right, so I think that's good. So slicing. So once you have the file, once you either make it yourself or you pay somebody to make it for you, you use this software. It's called a slicer. It usually comes with a printer or is paired with the printer. This one is called Bamboo Studio. This one that I use because it's the one that's paired with my printer. But there are many other slicing software. And also, my printer can use Orca Slicer and a handful of the other open source slicing software. What slicing is, in simple terms, is take your model and create each slice of the horizontal slices such that your printer can know what to do, and it will create the directions for the print head of where does it go, how hot does the print head get, how hot does the bed get, what is the speed of the fans, all of that stuff happens at this slicing phase. In here is where you would set all the settings of, like, if you're using a more advanced filament, you may want to, or I'll give you a specific example. In this case, this is a polycarbonate setting. So in this case, I had a number of settings to slow down the print speed. For the more advanced filaments, if you want to go slower, you're going to get hotter. You need that heat to transfer well. And I don't know the physics and the chemistry in detail, but generally you want those things to go more slowly for the advanced stuff. So this is
that saying 50 millimeters per second?
That's correct.
Oh.
Yeah. So that's half a centimeter per second. They're pretty slow. So it's pretty slow.
Okay.
Yeah. The more advanced, the more easier to print filaments go up to 200, 300 millimeters per second. That's really where it's flying around the print surface. Okay. Let's see. Anything else? Any questions so far? Cool. Okay. While you're slicing, okay. First of all, layer height. This is the thickness of each layer. When I'm printing or I'm testing just the fit or the size of an object, I'll print in thicker layers. It's faster to print in thicker layers, but you have less resolution, right? If you're printing a curve, you're going to have little steps throughout that curve, and it's going to be rough on the outside. When you're doing your final print in really thin layers, and then you have a nice, more smooth surface. Infill percentage. This is what defines the strength usually of the part. Higher infill, stronger, but also heavier and takes longer. There's a diminishing returns with infill. You don't need solid. Usually there's some YouTube videos on this where they do impact tests and whatnot. Usually 50 to 75% is really all you need. And in some cases, you even don't want solid because you have more internal stresses in the part. Print, so supports, talked about it a little bit, but if you're ever printing anything that that has a floating cantilever, they call it, you're going to need some sort of supports. Or you sometimes want to print something at an angle like this, and then you don't need a support if you can figure out how to print something in that way. So then you also decide your print speed. Faster speeds are lower quality. And the way that I think about this, if you take like a glue and you squeeze it out of a tube slowly, it'll come out straight. If you squeeze it out fast, it'll come out wiggly. And the same thing happens in a printer. And if you print really fast, you'll have these little wiggles all throughout your print, and it'll be rough and whatnot. Next one is the nozzle and print bed temperature. I think most of these come out of the box, depending on your printer, where you just set, I'm printing this material, and it'll give you the exact temperatures that you need to set, but not always. Some materials require cooler or hotter temperatures, so you may need to adjust these. And then the brim size and other advanced things, and I'll talk about brims more in a second. I have a picture. All right. Okay. Yes.
Maybe you're going to get to this. Range of filament sizes, diameters, cross section, what have you.
Yes. So there is the hobbyist one, I think is 1.75 millimeters. And then there's the industrial one that's like 2.8 or something millimeters. You're talking about diameter, right? Yeah. So oh yeah, so it's going to be whatever your printer is designed for. Most of the consumer ones are 1.75, and that's what all the cheap filament is. There may be some that are the larger filament. Generally, with the larger filament, you need a hotter print head because there's more energy going into it. And so I've just used the 1.7.
But you're not changing from, say, a half a millimeter to 1.6, 1.9.
No.
One size.
One size of the film. However, there are changes for the print head. And so I have a 0.8 millimeter print head. No, excuse me, 0.4 millimeter print head. And you can replace your nozzle, and with a smaller print head, it'll print more slowly. but you can get better resolution. So you can change that size, but it's still the same filament that we're going to. Oop, sure. All right. So filaments. So there's 5-ish primary filaments. This PLA is the most common filament. It is the easiest to print with. It's made of plants, and I think sugar, so it smells kind of sweet when you print. It doesn't warp. It's really cheap. It's really easy. This is the one that I use all of my, or I get for all of my prototypes. If I'm just, yes. These are polycarbonate. The first ones I did PLA though. The first ones, make sure that it fits, and I printed 4 or 5 different fits. Did those on PLA, and then once I got the fit that I wanted.
So
yes,
the different materials, they don't really change what it is when you first use like you said, use it as a prototype.
Yeah.
When you go to the real thing, it's exactly the same thing as far as.
For the most part, the texture, the feeling of it will be different. The physical properties of it. PLA is a harder material, so it is.
Is it more brittle?
It's more brittle.
Oh.
Yeah, so it'll crack.
Okay.
But
this has flexibility, but high tensile strength.
Yeah, this one is it's yes. So this PLA, if this was PLA, that would probably crack.
Oh, okay.
Yeah.
Are the heated beds used to slow the cooling rate so it doesn't internally stress?
Yes.
Okay.
Yeah. So if you print, comes out at 250 C, 500 something Fahrenheit, and it comes out, and you want it to cool as slowly as possible, because if you touches something cold, it's going to immediately warp. And so these are printed, the bed is 110 C. PLA prints at, I think, 35 C. Because it's just more resistant to the warping. So you can just print it. You can have a fan on in the room. It can be pulled out. Doesn't matter. It's going to be fine. And it's this big thing about this, at least for me, is it's cheap. You can get these rolls for $12 to $15 if you wait and find them on sale. You buy them in bulk. Whereas these other ones, these rolls are 55 to $60 each. So there's a big variability, and if you're just going to be wasting these parts, like when you are prototyping, just use the cheap stuff. All right, next. ABS. ABS is another common material that is used often in 3D printing. ABS, it's the plastic that car bumpers are made out of, as far as I know. It's a very strong material, and you can print it. And I don't print with this because my printer is in our guest room, and when you print, it smells. There's some toxic gas. I think it's styrene or something. It's very bad for you. And anyway, lower wife points when I print with that in the house. So I print PLA. I print these, and I close that door, put the towel on the floor, and put the fan outside to make sure we're okay. Yeah. What is that noise? It smells weird. All right. Okay, PETG. So this is another very common material, very easy to print, almost as easy as the PLA, almost as cheap as PLA, but much stronger. PETG is what water bottles are made out of. So it's generally non-toxic. Like these might have it on there. No, PETE. So it's close. It's a different type of PET plastic, but it's very, very common. And if you're going to be printing something that is going to be outside, this is what you should use. It is UV resistant and warp resistant. I did a test with some PLA parts, and I left them on the dashboard of my car, and on a hot day, and I came back, and they looked like little macaronis, or like little Pringle chips. They really warp, and it's pretty bad. So you don't want to make anything that's going to be outside or functional out of PLA. This one though, PETG, is fine. You can leave it outside. It's going to be just fine. And most of the other materials, like the polycarbonate, nylon, all of those are fine. Okay, next slide. TPU. Okay, so this one is, it's very hard to print, but it is a rubber flexible plastic. So I printed this Croc, just for fun. I'm gonna pass this around. I haven't worn it. It's okay. Sorry. And so you can flex it, and like in in this case, I printed it with 10% infill. So you can even feel it. It feels kind of like a sole of a shoe. It's spongy. And this one is the common type of TPU. It's 95A. There's a range of different flexibilities of this stuff. But if you're printing something that needs to be flexible or extremely durable, TPU is a good option. Because it's flexible, it's not brittle, it will never break. And you can make it really thick, and it becomes a very good long-lasting material. Some people print like brakes, or not brakes for cars, but brakes for machines out of this stuff.
What would be the cost of making 2 of those shoes then?
That one, I did the math, $5 for that shoe. Yeah.
Instead of 80.
Exactly. Yeah.
So we did
$10 for a pair.
I got crops.
That's true. Those material. Yeah, but I already made my money back from the other parts. So I'm $8,000. I've saved $8,000 now. It's yeah. This is basically paying us. So
When you have large open volumes like that, now, do
Yes.
you need to use an armature, or do you use some of those bridges you were talking about to hold its shape while it's cooling?
So yes,
Something
usually.
thinner, like a Trojan Pro-Lactic would be a lot cheaper, wouldn't it?
If it's really small, right?
I don't think it would volunteer to hold the armature, right?
So this particular shoe, I printed it. If you look on the back, there's a flat part, like right on the heel. And so I printed it at an angle like this, and I figured out I actually don't need any supports on the inside. And there was just 2 little sticks on the sole. And so it was very little material because of the angle that I printed it. But yes, generally, if there are open cavities like that, you're going to have to print supports on the inside, and the slicers take care of that for you. And then you have to pick it out with a little knife or a blowtorch. Sometimes people use. That was 12 hours. So there's a long time to print it, especially in this material. You need to print it very slowly, just to get it to go perfectly and to line up all perfect. And also, I'll talk about this too in a second, but I had to dry this material for 2 to 3 days. If you print a wet material, it just doesn't work. And this type of material, this TPU, is very picky, very finicky about being wet.
Will it deform during that time too?
If you dry it too hot, so because you have to dry it at a very low temperature, 55 C, I dried it. So the moisture is coming out very slowly. Took a couple of days of drying before the humidity stopped getting released from the material. Okay, next slide. Nylon. So this is the probably one of the more or most durable materials. There's PA6 and PA12 that you'll find online. I printed a handful of my parts out of nylon because I was looking for high temperature resistance, and nylon, specifically the one that I was found, was PAHT. I'll show you in a second. Has the highest temperature resistance. I think it can go up to 250 or Celsius or something without deforming or losing its significant structural properties. If you go to the next slide, shoot, I had 10 more slides, but I'll come back to it in a second. Okay, so the last one is polycarbonate. This one is a polycarbonate, also similar to nylon, very strong, very durable, high heat resistance. Okay, yeah, but very difficult to print. These parts all you have to print very slowly. You have to make sure that the filament's very dry. You have to have this brim. Is there a brim? If you saw that like plastic, like a flat piece of plastic, you have to use those brims, and there's little tricks to make sure that your part sticks to the brim. Anyway, very challenging, and you have to have a printer that can print these type of materials. Okay, next.
Are you able to work with any of the, say, higher spec synthetics, like a UHMW, something along those lines, that has certain technical properties that make it better than a nylon, red velvet, or Teflon, or?
Oh, so I have looked into Teflon. I can't. The printer that I have goes up to 300. There was a handful of properties, one called PEEK, that it sounds like metal when you touch it, when you like tap it, but you have to print it at like 400 or something. So those would require a more expensive industrial printer than at least what I have. Yeah, and Teflon, I think it was just completely impossible.
Some of you, like you assume, have used they create guides that are subject to wear and what have you, they're very resistant to wear. They don't cut the way a nylon would cut
Yeah,
in the metal materials, and that's it.
yeah, no, I'm sorry, mine doesn't. Okay, last one is fire resistant filaments. These for anything that was going on the inside of the plane that was even a little bit functional. My agreement with my A&P was that it needed to be fire resistant. And this is because I printed those first gray manifolds, and so we took a blowtorch to it, and it just completely went up. And we were like, oh, there's smoke everywhere. We're like, okay, this is not going to work. It was a fire. It was basically magnesium. And so he's like, go back to the drawing board and find something else. So I found these PCFR and PETGFR. This is for fire resistant. However, they're not actually fire resistant. They're self-extinguishing. It's different, but they're called FR. Both of these brands, True Cement PTG and Polymax PCFR, are UL94 Underwriter Labs certified V0. And that's the horizontal burn test. They have on their website the burn test that you can download. I didn't have to go get a test because he's like, it's gonna be, he looked at it. He's like, they tested it, it's fine. These ones you need to print at much higher temperatures. So they recommend a bed temperature of 90 to 105 for the polycarbonate, those white things that we were looking at. And a high chamber temperature. I'll tell you why in a second. A very slow speed, and this is a hot nozzle temperature. For comparison, PLA, the simpler materials, they print at around 220 and a 35 bed temperature, and you don't need any chamber temperature. It can just be open to the air. It's fine.
So the Polymax PCFR is polycarbonate, but it's a fire resistant formula.
Exactly. Yeah. So they put some additives. I'm not sure what they put some in there, and they say on there that the additives lower the structural strength of the part, but it's still a very good part. It's still polycarbonate.
So how many feet are on a rope?
1,000 meters. Wait. Usually 1,000 meters. Is it 100? No, I think it's 1,000. So it's 2.2 pounds per roll. 1 kilogram. I think it might be 1,000 meters.
3,000 feet?
I think so.
So your slicer give you a projection of filament to be consumed?
Yes. Yeah. So it'll tell you exactly the length and the grams of everything. I think it is about, well, now I'm second guessing. I don't know. Yeah, but I can't. But I usually do it by weight because every part is, let's say it's 12 grams. These are, I don't know, 5 grams or something. And I say, okay, $60 divided by 5 grams, 1,000 grams. Yeah, this part is that much. It's very cheap. Okay, next slide. Thank you. Okay, we'll talk about printers next. This is a very, very deep hole, and so we're not going to talk about too much, but I'll go over a couple of the comparisons. Number one question that you should ask yourself: do I want a new hobby that's 3D printing, or do I want to print for my hobbies? There are so many printers out there. You can buy a hobby printer and you can tinker with it all day, and some people love that. It's personally not for me. I want to be printing things for the plane or for my house or my wife or whatever. So ask yourself that question, and then you'll get to figure out, okay, the price and how much do I want to tinker, and there's going to be a point in there where you get to decide what printer you want. Next is what kind of materials. I knew that I was looking for high temperature materials, the nylon that could resist that high temperature that comes out of our little floor vents, and so I knew that I knew the material I needed to print. I needed a printer that could print that material, so that dictated the printer that I got. Then the printers have different size beds. The printer I have is 256 by 256 by 256, and that prints most of the things that I'm going to need. The cheaper printers have smaller print beds. Some of the more expensive ones have larger. You get to decide depending on your needs. And then, of course, do you have any other household needs? And this is what really won me my points. My wife loves, she has a million plants. So I started printing plant stands and little plant holders and stuff. And she would be like, hey, I really need a thing for whatever this, thing on the wall. I was like, I got this, and then the next morning I have a thing that exactly fits what she wants, except it's the wrong color. So I have to print another one. But it's fine, exactly it fit. And it was very useful and won me a lot of points. Exactly, right. They're saving money too. Right? So some of the stuff is, the pot stands, they cost about $4 in material, and she was telling me they cost 30 or 40 bucks on Amazon. And so every time, like, you want more of these? I can do it. We're saving money every time I print them. Anyway, okay. All right, next slide. Yeah. There's 3 general classes of these printers. Of course, many points can transition between the classes, but generally the lower class printers will have a table style called a bed slinger, where the bed will move back and forth. These are the older style printers, a little bit cheaper. Those printers are about 200 bucks right now. They print more slowly, and they print the more basic material, or more beginner-friendly materials, I should say. Some of the older ones, they have a fixed build surface. So it's like a piece of glass or a piece of metal, and it's stuck there. And in order to get your print off it, you have to scrape it off and like wedge it off with some sort of tool. The more from the mid and high level printers, they have a removable surface. And so, yeah, you've done it. You take the metal plate off, flex it, and the part pops right off. It takes 0 seconds. Let's see, they have the mid and high level ones, they have an enclosed case or space. So, and the point of the enclosure is to keep the heat in, to keep that part from cooling unevenly. The bed will get hot and will warm up the air inside of there, and then it's printing, and you don't have a big delta in temperature as it's printing. Yes. So some of these people online have some very advanced setups, multiple cameras and lights and everything. The higher end printers, they print 300 and up. Some of the very expensive, these are industrial though. They'll print 400 or 500, I think. I think the Ultimaker goes to 500. Anyway, the thing that you were looking for here though is the active heating enclosure, where it will actively heat up that space inside there to make sure that your prints the least chance of warping. Yes. Okay. So, next slide, please. So this is a couple of examples. This is the one I got. It's a new company. A couple of 2 or 3 years ago, they released this printer, and their goal was to bring the cost way down and take away all of the choices. Really. You have fewer choices. I call this it's like the iPhone. It just kind of works. You don't get to choose things. You can if you want, but you don't have to. You don't get to replace parts. You don't make it. It comes in this box. You take the styrofoam out and you can print with it. This thing here is called an automatic material system. What it is, there's 4 rolls of filament that are in there in a dry box, and it's holding on to the end of each of those rolls. Then from your computer, when you're printing, you just select which one you want and fire it off. It'll automatically feed it in and use that material to print. The alternative for this, it's about this big. Yeah, about that tall, and about the size of about a footprint of this.
Can you replace one color roll when you burn it out, or do you have to replace the whole cartridge?
Oh no, so you replace one at a time, and it has a feature where, so if I'm almost out of one roll, I put in a second roll of the same exact thing. When it runs out, it'll automatically move on to the next roll and continue printing. In other printers, your print is over, you have failed, you need to go ruin it, you have to go put in a new roll, and it'll continue that print or restart that print from scratch. It's very, I like it. Just this is the one I have, so I'm a little biased, but Oh yeah, I was gonna say it's loud. I was gonna say it's pleasing. It's pleasing. Okay. Yeah, you know it's running though.
Yeah.
So some people say they can sleep in the room, and to me that's out. Okay, a couple other features that this one has that also exists on other printers are there's a camera and a LiDAR sensor in the print head. When you start a print, it'll do a couple of things. It'll automatically level the bed. It doesn't actually level the bed, but it gets the leveling of the print surface, and then it changes how it's going to print by moving the bed up and down as it gets to that part of the print surface. The issue here is that if your bed is not completely, exactly, perfectly level, it doesn't stick. It won't stick to that bed. And the kit printers, you have to level them yourself. The more higher end printers, they'll come pre-leveled from the factory. And then anytime you start a print, it will go and measure and make sure that it's printing exactly level. It'll also check the print surface. Has LiDAR and the camera. It'll make sure that there's nothing on the print surface. And then on that first layer, once it's put that first layer down that needs to stick really well to the print surface, it'll check it and make sure that it's not coming up or has any other imperfections that are going to make that print fail. If it is going to fail, you get an alert on your phone and it says, go check the printer. You go and you scrape it off and you start a new one. And you don't have to be there and babysit it the whole time. It's $1,500 with the AMS, a little bit less with it. It costs about $250, $300 for the AMS. You can also combine these. You can get up to 4 of them, so you can have 16 materials ready to go. And just practically, I have a PLA, the prototype material, a nylon, and 2 polycarbonate. And so I'm at the hangar. I'm going to print something. I fire it off in PLA. I get home. It's correct. Then I change it to polycarbonate, and then I wake up the next morning and I have my part. I take it to the hangar.
How big is the piece we produced size wise?
This one is 256 by 256, 2 by 256. Yeah, about 10 by 10. Yeah. You can't go all the way to the edges. There's a couple of requirements, but generally, yeah, pretty close. They have some.
You say you can get that started on your phone if you're at the hangar and it's at home?
You can. And so I use my laptop because I want to use my own designs, but they have a whole website of parts that you can download. You can do that from your phone. And if you printed the part before, it's in your history, and you can just say, print this again. Yeah. And so anytime that I finish a print, I make sure to clean off the surface and make sure it's ready to go, because tomorrow, the next week, I can just fire something off.
Different colors, is that just color or is it different?
All of the whatever your look wants. So some people will do different colors. I just use different materials. I'm not really printing stuff for that looks cool. I'm more functional stuff.
Different types.
Yeah, I use different types. Okay, next slide. All right, so this is just another flagship. This one, it's called Prusa. It's very high quality printer, but you notice it doesn't have a case around the outside. This is one, it's kind of like the Android. You can change anything you want. You can upgrade the heck out of it. You can tinker with it. And it's very high quality and it's quiet from what I understand. I don't have this one. I was looking for more of the just always work printers. But it's a very high quality printer. People who have it love it. Just another example.
Does that keep you from printing pieces or materials that require chamber heat?
Yes.
Or do you build your own chamber heat?
So if you're going to print those things, you would actually you can print a chamber. So you print a chamber. You go and you buy the heater from Amazon. You print the bracket, and you print it. Yeah.
Okay.
So you can. The hobbyists, the nerds have done everything. So
what's really going to be scary is when you go away and you come back and it's done something to itself.
There's a second printer, so little printers next to it.
Like, wait a minute, I didn't change it.
Yeah.
No, you did not.
Someone has a printer. The printer prints itself.
Yes.
Someone did it on YouTube. Okay, next slide. Okay, common issues. We still doing okay? Yeah. Okay. All right. So for bed adhesion, probably the number one biggest issue is if the print comes off the bed. If it comes off the bed and you can see here the edges are coming up, it just can't print, the next layer in space. If that edge is coming up, it's not going to work. Usually what happens is the print head will hit it and it'll knock it off, and then you have a big roll of goo. Yeah, exactly. So if you have a printer that you need to level the bed, level the bed. If you have one of the ones that does it on its own, don't worry about it. Number two, this is what I do every single time where if something's not working, is wash the bed surface. So I use isopropyl alcohol to just clean it off a little bit. And then always Dawn dish soap. The blue, normal, cheap Dawn dish soap. For some reason, Dawn dish soap it just works magic. I don't know why. But that formulation, according to all of the 3D printing forums, everyone says the blue, cheapo, no additives, Dawn dish soap. Then after you wash it, don't touch the surface. Don't put your oily hands on it. Don't wipe it with a towel or a rag. Just air dry it and put it back on the thing, and that will solve 90%, at least of my issues. Skipping down, yes, sorry. Rinse the Dawn soap off. Yes, get it nice and clean. Lots of hot water after, but I still then just don't touch it. I use a paper towel to, agitate the soap and then rinse it off with hot water. Skipping down here to a brim or a raft. A brim is it is a little edge. It's that little plastic piece that you saw that holds the part. It extends the base of the part out a little bit more, and that helps it adhere to that bed just a little bit more. And let's see. How do I hold this up? There we go. Okay. This is a brim. All right. Next slide.
Has anyone played with heated vacuum tables? Because those are readily available. And you can dial the heat in pretty closely. But the idea is it's a subtle vacuum. I've used in art conservation, things like that. But they use it to pull paintings back down to their paint. Is going to reveal and that kind of stuff.
That's a cool idea. I don't know.
Okay, just curious.
Yeah, I don't know. I'll bet some nerd has done it. Okay, so warping. Other big issue is warping, especially if you're using anything aside from the PLA material. The way to fix it is print in an enclosure and turn off the fan. This is what will happen is that the little corners will come up or the entire print itself will warp. And what's happening here is that this material just happens to have a high warp factor. I don't know, tendency to warp. And sometimes I haven't really figured out how to eliminate it completely, just reduce it. And I don't remember if there was some posts about the armrests on the forum a few months ago. I printed some armrests. I could not get them to not warp. They absolutely warped every time. And so my solution was just to print them on the side so that warping is fine. I couldn't fix it. It's just going to happen. However, I was able to reduce it a lot by getting my my enclosure as really, really hot and preheating it for a couple of hours by turning on the bed to like 110, turning on the fan to get all the parts in there very hot, and then do my print after. Okay, next slide. It's an example of the brim. This is the little, the vents by our feet. And so this is a nylon, high temperature nylon with carbon fiber. And as you can see, it has this nice little texture on it. I love it. It's a good texture. So I printed a couple of them with a big brim. Turns out the brim was too big, and just the amount of plastic that was shrinking pulled itself off the table. So I printed these other ones with a little shorter brim. Those ended up working. It came up a little bit right there, but generally it was just the right amount of brim.
And that's the part you trim off. Right?
Yes, exactly. Yeah, I just pull it off usually, or take a little knife or a deburring tool and pull it. All right. So weak layer bonding. This is going to happen with the higher industrial prints. basically what you want is you want to squish the layer to the previous layer as best as you can. So you want the previous layer to be nice and flat, and you want that layer on top of it to be squished nice and slowly, perfectly on that previous layer. And if it's not doing that, it could be cooling. There could be a million reasons, but so like slowing down the print speed or getting it hotter so it squishes on better are the tricks for that. Yeah, okay, next slide. All right, so a couple of tools that you're going to need. Number one is a filament dryer. $60 for this one on Amazon, and it has some settings. So this one is PLA. You just throw in your roll into there. It has 2 little heaters and a little tiny fan, and they say dry it for 6 hours or whatever, and I just leave it in there all night. Leave it in there for a whole day, and it has a little humidity sensor. Once that stops going down, that's when I'm preparing that material. I'm probably overdoing it, but it's fine. I don't care. You don't have to use one of these. It's very common for people to use a food dehydrator, like things that make beef jerky. Take out the innards, and it fits a one or a couple of rolls in there. And those, as long as it is it can hit a temperature and maintain it. You don't want it to get too hot because then it'll start to melt the material. Then you have a solid chunk of plastic. Okay, next slide. Storage. So some sort of airtight storage. I use these. I just put every roll in here. It fits perfectly. And then I throw some desiccant in there, those little dried silica pellets. Some people use like these sealed boxes. They have clips, has a gasket on it, and they just put it all in there. I didn't do that. These were cheap and available at Costco. All right, next slide. These long needle nose pliers they have a little extender on them are incredibly useful. If you don't have one, I recommend it. This is a scraper. You can print these. So print it as soon as you get your printer. Print 4 or 5, and a deburring tool. I saw Ken had one of these. Yeah. So if you don't have one, get one. They're very cheap and extremely useful. All right. Okay. So the FAA. Yes. No. Okay. So I looked into it a bit when we were doing our logbooks. There's basically nothing. They, at least for general aviation, they have a handful. Like there's a advisory circular for powder bed fusion additive manufacturing for engine parts. That's not relevant to us. There's some slides for TSO applications for parts manufacturers, also not relevant. There was a workshop 2 weeks ago in Oklahoma, and they all met up, and I looked at the schedule, and it's mostly about how do you regulate part manufacturers who are using this technique or these techniques to manufacture parts. Some of the things from those slides were, how do you judge the consistency of parts? If you have 2 parts, how do you know that they're the same? Because in 3D printing, it's, if the humidity is different in the room, it's going to have different properties. So how do you do that? And that's the stuff they were talking about. Couldn't find anything else approved or not approved, which made it a little bit harder to sign off the logbooks. However, most of the parts that I installed were all minor alterations, so he didn't care. We could just put them in, except for the wire clips. And he's like, those, it's got to do with wires. We just want to make sure that everything is by the book. So I found in 43131B this section here, where it says wires and cables are supported by suitable clamps or other devices. The supporting devices should be of a suitable size and type, with the wires and cables held securely in place without damage to the insulation. And so we looked at these and we're like, well, are they suitable? I'm like, yes, it's totally suitable. It's not going to damage the insulation. It's better than the 3M little sticky pads. And so we used this to sign off the logbooks for those clips. If you know of anything else, let me know, because, well, actually, I'm already signed off, so I don't care. All right, next slide. Okay, a couple of final things that I didn't have a whole slide to put in. Tool racks and organizers are extremely common on these websites. They have drill mounts, there's pegboards, all kinds of stuff that you can print, organize your shop. And there's little bins, or many different sizes of bins, screw holders, whatever you want. You can download these files and print them. I do recommend that printer, the Bambu Lab X1C with the AMS. It's easy to use. And the fact that I can do stuff from my phone and from my computer. I could, from here, print something 1,000 miles away and it'll be there when I get home. Filament sales are common. Just if you're gonna be doing this, wait till they go on sale. You can get it 30–40% off. And if you buy 5 or 10, you have now enough to last you many, many months. The McMaster trick. I just learned this one. So McMaster, for almost every part, maybe every part, but every part that I could find, you can download a CAD file. So go in there and you can download a step file. That step file you can load directly into your slicer and print the part exactly as it would exist. So maybe you're not going to be using that part, but if you want to make sure that it's the right dimension, it's going to fit exactly, you just download it, you can print it, and then you can order it from McMaster. I learned this far too late because I've ordered way too many things that didn't fit and paid $10 shipping every time. If you have any problems, dry your filament and then just keep drying it. It is the #1 problem where people go on the forums, they say, my thing's not working, dry your filament, and then it works. Buy an aftermarket build surface. So the plates, the little flexible plates that come with printers, they're great, but aftermarket ones are better. It's about $50 and it's just a different, it's called PEI or PEX is the one I got. It's called Wham Bam. And just about everything sticks to it. It reduced my failure rate almost entirely. So I recommend it. It's totally worth it. Like I mentioned before, winning points, printing household items. Another example of this is chip clips. You know, we have a bag of chips and we used to use binder clips, but now I went online, I downloaded somebody's chip clip, printed out 10, and now we have 10 chip clips. And let's see, if you want something and it can be made of plastic, it is highly likely that someone has already made it and uploaded it to the internet. If you could think of it, it's there. Like that aviation, panel hole plug. I was like, man, gosh, I wonder if somebody's made this. And of course, 8 years ago, somebody did. You can find parts. This is just the handful of sites that you can find the parts. But I just Google. I just say the thing I want, STL, and it'll come up the first thing. Yeah.
So you said you do a lot of measurements, really good measurements and everything.
Yeah.
There's a lot of things out there that just they taper off. Is there a way to take a picture of something and it can do it?
There are scanners now. There are 3D scanners. They're handheld, and you wave them around, and it will create a part. I've never used one, but the videos are kind of impressive. They're $300 to $500. So I was like, I'll just.
Well, it's not just a picture; it's a 3D scan.
It's a scan.
Yeah.
What I do for I didn't have a picture here, but I posted on the forum. I made a mount. Oh wow, yeah. So that's like great.
Yeah,
that's really good.
It's a buddy of mine.
Yeah.
Oh wow. He's doing them all in full size. He's got the dog.
Is that a human size?
That's bigger than his daughter. It's built 7 parts.
Holy cow! Yeah, that's impressive.
Yeah,
Let me take
they're that accurate.
Too far back. Let me take a picture of this one.
So for curve surfaces, what I've done is I would trace it with a piece of paper to get that curve, and then I'll measure different
Points along.
with different points, and then I'll design those distances on a curve and just get it close enough. Yeah. It's not perfect. That's where you might want to use a parametric design for Tinkercad. It's not very good.
Talk a little bit about people being able to get these things printed.
Yes. Okay. So you can find the part, but if you don't have a printer, you can get them made online. There's countless sources of these. Shapeways is one. I've gotten mine on Etsy, where you just go on and you pay somebody, you give them the part, you tell them the material that you want, and they will print it and ship it to you.
Yeah.
They deal with all the crap that I mentioned about the corners coming up and the brims, and it costs maybe $30 to $50 for some parts. Some of the carbon fiber ones that I got were $100. And if you're getting one or two parts, that's probably the way to go. If you're going to be doing, a bunch of parts, maybe not. And at least for me, the more advanced parts I did get through a Shapeways or online distributor. But for these other parts, I needed to tweak them and make a lot of iterations. So I thought it was more reasonable to just print it and fit it myself. But it is absolutely an option if you don't have a printer or know somebody.
But you have to send them all the measurements or something?
Yeah, you send them the file. Just the file. You say, I want this in nylon, and they will mail it to you a week later.
Like the five.
Yes. That's how I got into it. Is my library. I went in there. I printed the vent manifold. There, it took 2 hours. I couldn't use it because the final print would have taken 8 hours, and they're like, you can't be here for 8 hours. But it was really great way to actually learn about it, and they took the time and showed me. It was fantastic. Yeah. They want to talk about it. They will talk about it for hours. Yeah.
Does Vanderbilt have built-in Wi-Fi interface, or is it Ethernet, or how is it?
It's Wi-Fi. So they have a industrial version that is Ethernet because Wi-Fi is not secure. So for commercial grades, you have to use Ethernet. But it's all Wi-Fi. Yeah, I don't think you can plug into it even if you want to.
You mentioned about having delayed subsequent courses and layers on tightly.
Yes.
If you've got an object that's a bigger track,
Yes.
will your slicer figure out saying, no, I'm going to build this whole wall, and then I'm going to go over here and build this wall because I'm going to have a chance to lay the next course down.
Wait, you mean if it's bigger than the build surface?
No, just if it's a larger, in other words, in terms of the time it takes it to make a path around the periphery of the object.
Yeah.
If it cools too much, you're not getting good adhesion to the next layer.
It is not smart enough. So what you have to do in those cases is you want it to print generally at the same speed per layer, and so you have to go. There's a visualization in the slicers where it'll tell you the speed and the time per layer, and you need either slow stuff down or change your fan speed so that they're cooling it at the right rate. Yeah, it's not smart.
Increase the temperature of the chamber,
Yeah.
or something like that.
Or something like that.
Can it do that where it's building up, like if you have two walls come up, and build up one wall and then go down and build up another wall?
If it's two separate parts, it can, as long as they won't hit each other. Like if it won't hit the little mechanism and they're far enough apart, it will do that. But generally, it's going to do all of it at the same time. Yeah. I think I have one more slide or anything else. No, that's it. Actually, I do have one more. So I printed out these little handles. There's like I printed 100 of these. Also, they're going in the trash if you don't take them. So I already have them at my house. So if you want some, please go ahead and take them. There are two kinds in there. So this is a 1/2-inch washer from McMaster. Like I couldn't get a washer that fit in the larger size, so I got the dimensions of that little washer and it fits in there nice and flush on that. So anyway, there's two different kinds in there. Take whatever you'd like. I don't care. Also, so I printed a couple of extra of these. So these are little Bose A20 battery holders. Somebody online made it, so I just downloaded it, printed it, and I put it in my plane. You can have these two. There's 4 up here. Please take them. These two, there are 2 that I also wanted a little pen holder. So I went into Tinkercad, edited the part, threw a cylinder on it, and it fits a pen, and also 2 little AA batteries for the Bose. Anyway, also go in the trash if you don't take them. So yeah, we could fight for it. So that's it. If any other questions,
That'd make good Yankee swamp.
Yeah, they do.
Don called it.
Are you talking about the differences, the size of that?
Yeah. So the inner one where the corners touch the cylinder, those are the smaller ones that fit that part, that fit that little washer. Yeah, so I have them on the outside and on the inside. 3 of mine broke, so
I want 2 doors.
yeah, yeah. Everything was broken. It was almost like that other plane. So that's it. Any questions or anything? I'd be happy to answer.
Great presentation.
Yeah, that's great. Thanks very much.
No problem.
Files on the.
I will. And these are polycarbonate too, so they're temperature resistant. They can go to 200 or negative, whatever. If you're going in the high altitudes, it should be fine. Yes. So I went overkill and I got the high temperature nylon. It's a PAHTCF is what they have it online, and it goes up to couple hundred. It gets really hot, so it probably would be fine to use these other ones, but I just said, I don't like the ones that I took off were all warped and cracked and whatnot.
Hey, before everybody runs off, just a couple of quick things. First of all, I want to thank all the presenters. You think about how much time it took to put these presentations together, so thank you all very much. Timeline tonight. Of course, the O Club is going to be open at 5. These doors open back up at 6. We'll have a cash bar in here, as I mentioned. Bring cash because it is a cash bar. And expecting dinner to be ready about 6:30. Yeah, there will be a table set up front for the gifts. Let's see. Fuel. Remember, you do get $1 off the fuel truck price. So make sure you arrange that with the FBO. What was everybody told about returning Enterprise cars?
Leave them at the FBO.
FBO, give them the key.
Give them the keys.
FBO, drop the keys. Perfect.
You will take the name?
Yeah, that would be good. Yeah, okay. Right. Hey, please take your trash out of here just so we don't, leave a mess for the staff to clean up. Appreciate it. Thank you.
Somebody had designed it already. It was so easy. Yeah.
So this is opposed to, I give them the right answer.
Very nice.
People ask about these. They're going to be on YouTube, not on the board. We have links to the board, go to YouTube.
Yes,
So I don't have home.
You don't even have to log into the
Oh,
forums.
the air.
On the left column at the bottom,
Oh, not that
YouTube.
one.
it goes right to our page. Do you know why their color is that color?
Yeah, because they eat shrimp.
Are they
Shrimp
plastic?
they
Are
eat,
they-
yeah.
Oh, we tried that. Some?
Oh, my
Saw some of those, we were down in Curacao this last, and it's like, yeah, they're really that color. I mean, they're that bright.
Yeah.
And they were like, oh yeah, it's all shrimp.
If they have a shrimp coat or something like that, then they start changing.
Yeah.
Thanks for joining us, folks. We're signing off here.
Great work, Tom. You can be